We're going to talk about dividing radical expressions. Now, this is the second part of lesson 6.2. Dividing radical expressions are similar to multiplying. If you have a fraction with two different square roots, you can write them as 1. I'll bring them together here. I've got my 63 over 7. So bring your numbers together. Let's look at the x separately, and then bring the y's together. Y cubed over y. Go ahead and simplify whatever you can. 63 divided by 7 is 9. X I can't take the square root of, so it's just x. But let's look at the y's for a minute. If I have 3 y's in the numerator and 1 y in the denominator, one of those cancels, and that leaves me with y squared underneath my radical sign. Do we know what the square root of 9 is? Yes, it's 3. Can I take the square root of x? No, because it's not a pair. It stays inside. And how many groups of 2 are there in y squared? There's one group. The square root of y squared is just y. And my answer is 3y times the square root of x. Look at number 8. It's already written under one radical for me. I can tell that it's a fourth root, so I'm going to be looking for groups of 4. Let's go ahead and separate it out. I'm going to look just at my numbers. 243 over 3. And then look at my k's. K cubed over k to the 7th. Looking at 243 divided by 3, it gives me 81. And looking at my variables, if it helps, you can write them off to the side. I have 3 k's in the numerator and 7 k's in the denominator. 3 of them are going to cancel, leaving me with 4 k's in the denominator. I could write that as 1 over k to the 4th, or 81 over k to the 4th. So just like in number 7, we had 2 different radicals we rewrote as 1. You can take one radical and rewrite it as 2. I can separate them into the 4th root of 81 and the 4th root of k to the 4th. 4th root of 81 is 3. There's one group of 4, so one of the k's comes out. Right? Notice that k was in the denominator. All of the numerator canceled. It was in the denominator. It has to stay in the denominator. Number 7, the y's stayed in the numerator because the denominator canceled out. So you have to pay attention to where your k is located after it's been simplified. Number 9 and 10 are slightly different. On number 9 and 10, the denominator doesn't simply divide out. We look back here at number 8, 243 over 3, it simplified into a whole number 81. I can't simplify 1 over 5. So what I'm going to do is called rationalize the denominator. I have to get rid of that square root. In order to do that, mathematically, I can add anything I want to a problem, as long as I do it legally. I can put another 5 in the denominator. Mathematical law states that if I do it to the denominator, I also do it to the numerator. So let me rewrite this. In my numerator, I have y and 5. In the denominator, I have 5 and 5. And the reason that I do that is I now have a pair of 5s. It's a square root, so I'm looking for pairs of 2. That pair of 5 comes out, and I lose the square root sign. Nothing can be simplified on top, so I simply leave it as the square root of 5y over 5. You cannot reduce these two 5s. Whatever's inside the radical is protected. You can't touch it. So let's look at number 10. When I'm rationalizing the denominator, all I'm looking for is what's under the radical. I need to get rid of this radical 3. So in order to do that, I need a second 3 inside. I can put a second 3 there as long as I also put one under the radical of the numerator. So let me rewrite this. 6 square root of 2x times 3, 5 square roots of 3 times 3. Here's my pair. It's a square root, so I'm looking for pairs of 2. This 1, 3 comes to the outside. So I have 6. The 2 and the 3 remultiply, giving me 6x. I pull the 3 to the out and multiply it with the 5. This is 5 times the 3. In my last step, I can reduce. You can reduce 6 over 15. Remember, you cannot touch what's under the radical. So 6 over 15, I get 6 divided by 3 is 2. 15 divided by 3 is 5. And my final answer, 2 radical 6x over 5. So let's try one more. We'll do one more together and then let you try number 12. On number 11, I'm dealing with a cube root, so I need groups of 3 to pull out of the radical. So let's look at the denominator. I have a square root of 3y, or cube root, sorry. And then the numerator was the cube root of x squared. Okay, to get groups of 3, so I can lose this radical in the denominator. I have 1 3, so I need 2 more. There's 1, 2, 3, that's a group of 3, and I can pull it out. Do the same thing for the y. I've got 1, so I need 2, 3. You're going to have to add 2 more. And whatever you do to the denominator, put the same amount in the numerator. I've got 1, 2 3s I put up, and 2 y's. Now I can simplify. Looking for groups of 3, 1, 2, 3. That comes out. Groups of 3, I've got 1, 2, 3 y's. So it comes out. and then remultiply for the numerator. 3 times 3 is 9, x squared, y squared. Now, I'm not looking for square roots, I'm looking for cube roots. And that is my final answer. So go ahead and give number 12 a try. Push pause while you're doing your work and then recheck when you're done. This is the solution I got to the problem. I had one of the 3's and I needed 4 in order to pull it out of the radical. So I added 3 more here in green. And what I added in the denominator, I added in the numerator. I had 2 x's already and I needed 4. So in red, I added 2 more. I did it in the denominator and the numerator. So my denominator, I had a group of 4 for both the 3 and the x. And I remultiplied everything, and I got 54x cubed for my numerator. So that completes dividing radical expressions. Let's work a couple word problems. What is the area of a rectangle with a length radical 175 and a width of radical 63? Area of a rectangle is length times width. So take 175 times radical 63 and you finish out the problem. This is how I began my factor tree. I multiplied 175 times 63 and got 6,300. Let's try that again. 175 times 63 is 11,025. That I can take the square root of and get 105 inches squared. And then our last problem, they tell you the area of the rectangle. So again, area is length times width. My area is 30. My length is the square root of 75. And I need the width. So we are going to divide by the square root of 75. So the problem you need to finish is 30 divided by square root of 75. You need to rationalize the denominator and simplify the problem. When I rationalized the denominator, I took the square root of 75 for both numerator and denominator. That gave me 30 radical 75 over 75. I then simplified radical 75 into 5 radical 3, which brought me down to this step. The only thing I have left now is to reduce my fractions. 5 into 75 is 15, and 15 goes into 30 twice. And my final answer is 2 radical 3 meters. And that concludes lesson 6-2. You can now multiply and divide radical expressions.